Financial options, machine learning number 1. TensorFlow classification exercise on historical spread profitability. We have an options intelligence engine. We call it AlphaSeeker. And with AlphaSeeker, we pull the options chain and we're able to filter the data such that we can simulate trades. And so we simulated 3,900 trades. These are calendar spreads and bull puts. There are other strategy types that we could use. There were 637 profitable winners. The unprofitable trades were 3,300 of them. So we had a win rate of 16%. The few winners we had a return of 70%, and the losers lost about 300%. And you can see here the trade entry dates, May 2nd, May 5th, May 6th, May 7th, May 8th, May 9th. A total of 9 days of entry dates. And we had 1,600 trades with NVIDIA, 766 trades on the ETF SPY. IWM is another ETF, Palantir, QQQ. So these are the tickers. And these are the entry dates. And we just wrote some Python code to pair the spreads. And then we closed the trades and we came up with 600 profitable winners and 3,300 losers. And so the win rate of 16.01%. Now we can add other strategy types. There's much room for improvement in AlphaSeeker, which is where this is. But today we really want to look at our machine learning paradigm. So just like we have a score sheet for our trade, we have a score sheet for our machine learning models. And that is what you see here. This is the confusion matrix for the Athena Nike classifier. There's enough models around here. They have to have names, otherwise you can't keep up with them. So what we're looking at here is the total number of correctly predicted trades. We had 1,000 trades in the sample. We trained the model, and of 1,000 trades in the sample, it got 330 of them correct as not profitable. Here, the model after training, it got 419 entries correct as profitable. Now, there were 157 trades that it predicted were profitable that were actually losers. And then over here, we predicted 83. The model predicted 83 to lose, but they actually made money. So from here, because we're doing classical mathematics, we know how many won and lost because we can add and know from the P&L whether it's a winner or a loser. Over here, we didn't use the machine model to look at the actual win and loss. We looked at 45 traits of each side of the spread to tell us which ones it thought were going to make money and which ones it thought were going to lose. So we do a little bit more mathematics, and we're going to find out that our model had a correct prediction of about 73%. And you don't just have to take my word for it. We're going to go take a look at the model right now. At the end of this presentation, I will give you a slide so that you can find this on Kaggle, the data science machine learning website. This notebook is called Options ML Number 1 TensorFlow Classification Exercise. Predicting Profitability of Option Spread with TensorFlow Decision Forest. We talked about the 1,000 simulated trades, and here's our code. And as part of the notebook, each code cell is preceded by a short explanatory markdown cell to clarify the workflow. So each cell, I tell you before what it does. So on cell 3, here's the explanation. And then here's the work. Here's where it loads the training data. It's actually the complete data set for our exercise. Loaded 18,000 rows with 47 columns. So each column is a feature that we use to train the model. Here's a sample of what it is. You can see the SPY, ticker symbol, the calendar spread, and the expiration date of the contract and the short strike. So we have the same contract used as entry and exit for all 4,000 contracts that we paired together and made the spreads here. So we label these. We labeled them as winners and losers, 0 and 1. So we have a lot more losers than winners. And we had to massage the data set, as you often do in machine learning. Cell 5, we do a lot of things in here. We balance the data, because when you have too many samples of one type, the machine is not going to pick up the signal from the other side. So it's not going to be able to find any winners. And this commentary is the subject of our discussion. And it goes here, this is machine learning and what we're going to have to do. So here are all the features. The credit per width, the alpha per days, long ask, long bids, the long gamma. You have the long side of the trade and the short side of the trade. We trained the model. It didn't take long to train the model on this machine. She's very nice. So here, the model is compiled, and this is actually our matrix, the confusion matrix that we looked at before without the graphic. We repeat the graphic again at the bottom. We calculate the loss, and we do more machine learning. Good quantifiable information here. Feature importance sum score. So it tells us what the most important features are in determining how to adjudicate the disposition of the items that we're classifying here. Short ask is important. Strike distance is important. We have decimal days to expiration, and we have decimal integer expiration. And these ultimately come out of the database tables in AlphaSeeker. So AlphaSeeker has a lot of things that we can really, that thing needs a lot of work itself. But here's our model, and we are validating the model's predictive power. And this is where we get again into our confusion matrix. How many labeled items were correctly predicted? To verify that our model works, we don't look at the label saying whether or not it's profitable. It's going to look at the other factors, and we're looking at whether or not it's able to match what the actual true label is. So this is your foundation model for getting into options trading with machine learning. Thanks for your time. Oh, and I have the slide to get more info.